Hi everyone. Today we're going to have a quick look at some basic operations with surds. So surds are things like the square root of 5. It usually involves a radical sign like this, a square root, a cube root, something like that, and not a perfect square number or a perfect cube number, etc. Root 5, if I was to use my calculator to try and see what root 5 looks like, you see how the decimal doesn't terminate and doesn't repeat. So if I was to try and write that out, I could never do it. It would go forever and there'd be no repeating pattern. It's exactly what makes it an irrational number. So a surd is an irrational number. If I had things like root 5 multiplied by, let's go root 6. Now, I could check this on the calculator. Let's start this again. I go root 5 and now put it exactly the way it showed there, root 6. And you see I get about 5.477. Let's just remember that, 5.477. Now let's try going root 5 and we combine the 5 and the 6 together. We get the same thing, don't we? So often when working with surds like this, we'll simply go, well, that's the same as 5 6s are 30. It's the same as root 30. Good so far? Let's hope so. Now let's try another one. What if we had something like root 18 and we were dividing that by root 3? Let's go back to the calculator as a demo of this. So I'd want to start with a fraction and I want square root 18 over square root 3. And that's about 2.449. Let's remember the 2.449. Now, I think that that's going to be the same as if we combine the 18 divided by the 3 inside the surd. So let's go square root of the fraction 18 divided by 3. And we get the same 2.449. So we can see here that that's the same as square root 18 over 3. And 18 divided by 3 is 6, same as root 6. Now, there's your basics of working with surds. We can multiply surds, we can divide surds, and combine them into a single radical sign, a single surd. Now, as long as they are both the same type, these are all square roots that I'm dealing with, aren't they? If I was to try and do so I'm just going to make a note that that's true and that's true. Now let's try one that is a common mistake. This is a bad thing. If I did root 5 multiplied by the cube root of 6, I'm in trouble now because I have different types of surds. You see it's a square root there, but it's a cube root there. It would be a big mistake to try and write this as some sort of a surd with the number 30 underneath because they're fundamentally different. So this one, do not try to do that one. I'm not even going to write down. I'm just going to say beware of things like this. The rule that we have just seen here doesn't apply if the surds are of different nature. Now let's have a look at another example that does work. What if I went 2 root 3 multiplied by 7 root 11? Well, this is all multiplication. I could just I could leave the 2, then I could put the 7, then I could put the square root 3, then I could put the square root 11. Because all of those terms there are multiplied together, we can shuffle them around without upsetting anything. Now 2 7s are 14, and as we've already seen, root 3 by root 11 would be the same as root 33. That's a simplification compared to how we started. What if we did another one here? What if we had 14 root, or let's go a good number like 21, and we had that all divided by 2 root 3. That looks pretty good. Now, we could go 14 divided by 2 is 7, and then we could go 21 divided by 3, the surds, is also 7. So that one could be simplified to 7 root 7. That's pretty much all I wanted to cover in this little segment, is just manipulating surds with multiplications and divisions. When it comes to adding and subtracting, don't do it. It doesn't work. It's not true. If I had something like root 25 minus root 5, it's 2.73. Now you might be tempted to say that's the same as root 20 because you might be tempted to use the subtraction combining into a single surd. Let's just remember the 2.73 there, and let's check what root 20 looks like. Not the same, doesn't work. So when using surds and doing this type of work, it's only going to be true for multiplying and dividing, not for adding and subtracting. Okay, thanks for watching.